Dear students, very good morning. This is Professor Subramanya Bhagwat, your computer science coordinator. Welcome back to discrete mathematical structure. Last class we completed first model. Second, third and fourth models, continuation of first model and that contains problems. So when college reopens, offline classes through we study second, third and fourth model. Fifth model is entirely different. Discrete mathematical structure is divided into main two parts. First, second, third, fourth models enter discrete mathematical structure. Fifth model is entirely different. That is a graph theory. So online, what we do in YouTube videos through this series through, we complete online fifth model. First and fifth we complete online, and second, third, fourth we complete offline. So welcome to fifth model. Now I'm going to start fifth model. So first and fifth we complete in online. Fifth model is a very easy model. That is a introduction to graph theory. What is that graph? How do you define a graph? Types of graphs. We study here types of graphs. What are different types of graphs available? And examples, definitions first we study here. These are all the objectives of graph theory. Definitions, examples, subgraphs, complements, graph isomorphisms we'll study. Then tree definitions, properties, examples, rooted tree, tree sorting, and weighted tree and prefix codes we study. Now, what is a graph? How do you define a graph? Graph G contains a set of V vertices and set of edges E. But what is the definition? What is the definition of graph? Graph is a pair of that I call V and E, where V stands non-empty vertices, non-empty vertices, and E is a set of this what I call edges, set of edges, where graph G of VE, let me tell you. So the concept will be very clear to you. I am telling you G of VE. Okay, when I write this a graph contains graph we define like this G of VE, where set of non-empty vertices. In any graph, vertices should not be zero. There may be minimum one vertex, okay, but set of edges. Edges may be zero also. That graph is called null graph. Suppose I will take one point or 2 points, okay. I give a name A, B. Okay, no doubt it is a graph, but null graph. I call it as null graph. So we understood. Wait for 2 seconds. We have understood graph contains a set of vertices and set of non-empty vertices and set of edges. Okay, so I call it as this a graph. Now, graph is a pair of VE where V is non-empty set and vertices should not be empty. So, non-empty vertices, minimum one vertex must and should. E is a set of unordered pair of elements. Okay, so I write like this: G in bracket V of E. This represents a graph. This represents a graph. Okay, V is called vertices. Okay, E called edges. E called edges. If you observe this, these are all the types of graphs. I call it as graphs. Okay, here if you observe this, okay, three vertices, okay, zero edge. This is called null graph. Okay, example, another these things you see here. Order and size. What is that order and size? Okay, just wait. Okay, I'll take one graph. If I take one point, this is also, remember name should be written. If I take one point, this is also a graph. Null graph, I call it as these 2 points, B, C. Okay, this is a null graph I call, or one edge. This is also graph, and this is A, B, and C. These are all vertices A, B, C. Okay. Remember, First one is a graph of this. This is a graph of, okay, one vertices and zero edges. Will you agree my point? Yes. Second one, this, okay, graph of two vertices, one edges. Because two vertices BC and wait, two vertices BC and one edge is, okay, BC edge. Next one, okay, third one is a graph of this, I'll write here so the concept will be very clear to you. This graph, if you take, okay, A, B, C, three vertices will be there. Three vertices, okay, three vertices. Vertex set contains three vertices, A, comma, B, comma, C. Okay, will you agree my point? And edge set, edge set contains AB, one edge AB, BC, and CA, another edge. Okay, so three edges. This AB, BC, CA, three edges. So we understood this graph contains three vertices and three edges can be represented by like this G3 of 3. So that, okay, three vertices A, B, C, three edges. Okay, three edges. What are three edges? A, B, B, C, C. Okay. So this is a graph of three vertices, three edges. Okay. Next, okay. If you observe, these are all the graph definitions. Wait for 1 minute. Yeah. Now, next, very important, the graph definition is one thing is very clear to us. That's a graph contains a set of vertices, set of edges, but you have to write very clearly set of non-empty vertices. Vertices should not be empty, but edges may be empty. That time it will call null graph. Now, next very important thing is order and size. Number of vertices in a graph, we call it as order. Number of edges in a graph, we call it as a size. Okay, this example, this you take. This is A, okay, this is B. Two vertices and one edges. G comma 2 of 1. Where 2 is nothing but number of vertices called order. And 1 is called number of edges called the size of graph. Like this way you can write it. Directed graph. What is a directed graph? Where if edges direction is there, then it's called directed graph. Example, no doubt this is a graph. This is A, this is B. Two vertices are there. One edge is there, A, B, this is a graph. Where if I give a direction, like this is called directed, edges are available. This is called directed graph. While writing a vertices set is no problem, same. Vertices are, okay, vertices set same. V is equal to A, comma B. Two vertices are available. Where edge is considered, you must write here directions very clearly. Edge is AB. You should not